So fluorine is going to be my example. My first fluorine, I'm going to write on my board. Oh wait, I'm sorry, I need to be 2. I'm going to write an F, and then, actually no, I did find out that 4 is better. So I have my first fluorine, which I'm going to write to the left so that I have room at the right to write my second fluorine. Fluorine, if I look on the table, has 7 dots. Now, I want my other one to be to its right, to its east. So I'm going to do 1, 2, 3, 4 dots like normal. Then I'm going to do that right away. Then I start pairing. Here's my 5. Now, normally I would put my 6 here because I like going clockwise, but I don't want to put my 6 here because I want to put my other fluorine there. So I want this to be my active bond. So I put my next one here and my last one there. 1, 2, 3, 4, 5, 6, 7 dots with my open space over this way. That allows me then to put my other fluorine here. This fluorine is also going to give 7 dots. So here's my first dot. Pro tip, make the bond right away. So there's 1, 2, 3, 4, 5, 6, 7 dots. You'll notice 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Both of these are now happy. They've got 8 dots each, and I've got 1 bond between them. Structural wise, I've got my blue fluorine, my red fluorine, and a single bond connecting the two because there are 2. So because there were 2 dots, that becomes 1 line. So 2 dots becomes 1 line, boom, structural. Now, oxygen, draw my oxygen. 1, 2, 3, 4, 5. I want to put my other oxygen here, so I'm going to put my 6 dot that way. Because oxygen has 6 dots based off the table. Put my other oxygen next to it. And that was a little far away, but okay, that'll be fine. That's a bad place to put it. I'll put below. 1, 2, 3, 4, 5, 6 dots. Now my bond here is good, but if I count 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, neither of these have 8, so right now they're not happy. They're not happy at all. We want to make them happy. Now, to make them happy, you may notice that there is a spare dot on each of them, right there. That means there can be 1 bond each of these can make, so why not make it with each other? To draw a second bond, what you want to do is erase one, write one. You erase a dot, then you write a dot. So I erased an orange, I write an orange. I erase a green, I write a green. Like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Suddenly, we're not unhappy. We're happy. Both sets had 8, and that is great. Now, when I draw my structural formula between my 2 oxygens, I am sharing not 2 dots, but 4 dots are shared, which means this is a double bond, which looks like an equal sign when it's written horizontally. So there is your double bond with oxygens. Now, at this point, I would like you to try nitrogen on your scrap paper, etc. I will tell you that if you did everything proper, you should know that nitrogen has 5 valence electrons because it was the number 5 that we wrote at the top of our table. I want you to try nitrogen over the next 2 minutes, and then I will show you. But this is a chance for you to see if you've been paying attention and you understand how to draw dots and how to connect bonds to each other. 2 minutes, good luck. Sorry about that. We have 1 minute remaining. Just going to give you 30 extra seconds. Okay, so we have 5 dots. 5 dots when it comes to this. So, let's get this set up properly. So my first nitrogen that I write has 1, 2, 3, 4, 5 dots. And my second nitrogen that I'm going to write has 1, 2, 3, 4, 5 dots. Notice I made the bond right away. Now you'll notice there's only 6 dots around each nitrogen. That's bad. But we have 2 possible bonds that we can do. We can do a bond between here, and we can do a bond with these 2. So we've got 2 different bond opportunities, so let's do them and see if that solves our problem. So erase 1. I erased one of the pink dots, and I write it, erase 1, write 1. Okay, then I get a matching orange dot. Erase 1, write 1. Still not done, but I've got 1, 2, 3, 4, 5, 6, 7, and 7. Well, let's do that again then. Ooh, little too much erasure. Erase 1 of my pinks, write a pink. Then erase one of the oranges, write the orange. And there we go. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 is great. So in this case, I have got nitrogen and nitrogen, but what they have is not a single bond, not a double bond, but a triple bond. 6 dots makes a triple bond. So here we go, single bond, double bond, triple bond, beautiful. Now so far all of these have been diatomic or social elements, meaning it's 2 copies of the same element. We can have elements of different styles with as well. Water and CO2 as my examples. Okay, now, pro tip, water and O, hydrogen and oxygen. Oxygen makes 2 bonds, whereas hydrogen makes 1 bond. So you always want to do the one with the most bonds first. You want to do it first, and you want to do it in the center. So I want to start by putting my oxygen in the center. And oxygen has 6 dots, 1, 2, 3, 4, 5, 6. And then I want to put my hydrogens on. Now, each hydrogen only gives 1 dot. So I'm going to put my first hydrogen here, gives 1 dot. And then I'm going to put my second hydrogen down here. It gives 1 dot. And there we go. 8 around the oxygens, 2 around each hydrogen, which makes it great. Now, pro tip, hydrogen is always last. out of all the elements, hydrogen's the easiest to put in, so always do that one last. And carbon is the most important, so you always want to do carbons first. So carbons first, hydrogen's last, just as a pro tip. Now when I draw this structural formula, I've got H bonded to an O bonded to an H. Now you might be like, Mr. D, this one had H, O, H. Which of these is right? Well, they're both right. Both right. That's correct. That's correct, because remember, north, south, east, west doesn't matter, and we can change it any time. What matters is paired, unpaired, and bonded. And in this case, we've got two single bonds from hydrogen to oxygen either way. So they both work. Now, carbon dioxide is a bit trickier. We're going to start with our carbon, which has 1, 2, 3, 4. Then I'm going to have my oxygen, which has 1, 2, 3, 4, 5. Notice no one else here. 6. Say 2, 2, and 2. Then I'm going to have my last oxygen over here. 1, make the bond first. 2, 3, 4, 5, 6. Now you'll notice each of the oxygens have 7 dots, the carbon has 6 dots, but there is available bonding opportunities here and there. So we want to make those bonding opportunities because it turns out you're going to need double bonds. When we do this, remember, we erase one, write one. That is how we always go. So I erase a blue, I write a blue. I erase a purple, I write a purple. I also highly recommend color coding. Really, really, really recommend it. It just makes it a lot easier as you are learning. When you get good at this, then you can choose not to color code, but again, you are learning, so color code. I erased another purple, write another purple, then I erased my red, and I write a red. You will notice 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everyone has 8. Everyone is happy. So this is a good, stable molecule. We know CO2 works. To write this in our structural manner, we've got our 2 oxygens. We've got our carbon in the middle. Remember, the thing with the most bonds is typically written in the middle. And 4 dots equals a double bond. So O, double bond C, double bond O. Beautiful. That is carbon dioxide in its proper structural form. So that's your crash course on bonding. Now there's all sorts of bonding practice that you can do here. You can do I2OCl2, and then it will show you the answers, both electron dot and structural. And you can just keep looking at this. Sometimes I have notes to help you out. So please click through and try all of these.